One of the most important things to understand before starting out in 3D is how PBR works. PBR stands for physically based rendering, which is a rendering system that mimics how light would physically behave in the real world. Using this approach makes it very easy to create accurate materials that work in any sort of a lighting setup. So let's see how it works. There are two PBR workflows, metallic roughness and specular glossiness. Metallic workflow uses a metallic texture to tell the shader which parts of the surface are metallic, and specular workflow uses specular maps to define the color and the intensity of the light bouncing off the surface. I will be focusing on the metallic roughness workflow since it's the one most widely used, and in my opinion it's better. There are 6 textures and each of them adds different information to your shader. Most materials don't use all 6 of them though, so let's talk about what each of them does. Let's start with the base color, since it's the most important one. You will also hear other people refer to it as either a base color or albedo or diffuse, but they all do the same thing. They basically just tell your material what color it's going to be. You are pretty much always going to be using that since your material needs a color. The other one you're most likely going to be using all the time is the normal map. And what this one does, it basically adds 3 extra detail to your material. It makes it look bumpy. The next texture is the roughness map, which, as the name implies, it adds roughness to your material. It is a black and white texture, with white areas representing the parts of your material that are going to be rougher, and therefore not as shiny, and black areas mean that they are less rough and more shiny. A metallic texture, again, as the name implies, adds metalness to your material. It is another black and white texture, kind of works as similar as the roughness map. Black areas mean your material is not metallic, and the white areas mean that it is metallic. Displacement maps kind of do the same thing as the normal map. They're used for adding bumpiness to your material. White areas mean that the parts are going to be higher, and black areas mean that the parts are going to be lower. However, they're not as useful as normal maps because they need to actually physically change the shape of your model, which requires a higher resolution model. In older game engines, that was a problem because it took quite a big toll on your performance. However, we're using Unreal Engine, and with Nanite, that's not a problem nowadays. And the last texture is the ambient occlusion map. What this one does adds ambient shadows or context shadows into areas that are not directly lit. Basically, it makes cracks and holes such as these darker when they are not directly in sunlight. Put them all together and now you have a material that you can apply to your scene.